Lab 4. Determining the charge to mass ratio of an electron. Intro. In this lab, we measured the charge to mass ratio of an electron by creating a beam inside a gas tube, which makes the beam visible, and bending the beam into a circle with a magnetic field. Given the field strength, radius of the beam circle, and voltage on the electron accelerator, the charge to mass ratio can be calculated using the equation 2V divided by B squared divided by R squared equals Q over M. Once the setup is completed, use a multimeter to measure the voltage on the accelerating plates, as well as a multimeter to measure the focusing potential and another one to measure the current delivered to the solenoids. The focusing potential is not important to the E over M value, but helps make the beam more visible. When turned on, the variable currents supplied to the solenoids are used to bend the beam into a circle, such that the beam hits rings around the base of the accelerator. These rings have a glowing element in them that will glow when hit by a beam of electrons, and thus let the user know the diameter of the circle of the electron beam. By creating multiple different combinations of accelerator voltage and solenoid current to hit one of the four glowing rings in the apparatus, once around 12 datasets are collected, turn off the apparatus. Oh man, I'm noticing mistakes in here. And they should not be left on for more than 20 minutes. The data recorded that was important to the result was the voltage of the accelerator, the current supplied to the solenoid, and the number of ring that the beam was calibrated to hit. The data collected was as follows. In order to use the equation 2V divided by B squared R squared equals Q over M, the ring number and current must be converted to radius distance and a magnetic field strength respectively. The conversion of the ring number to distance happens by knowing that it is as designed of the apparatus, the rings are spaced half a centimeter increments from the center. So by multiplying the ring number by 0.5 cm will yield the diameter of the electron beam circle. Andrew, I have to go do some corrections.